Alright, so today we're going to be talking about some basic rules for taking indefinite integrals, or another easy way to think of this is a good way to take antiderivatives, or my favorite word, primitive derivatives. That's a great way to think of it. So indefinite integrals, well, let's refresh ourselves really quickly about what we mean when we say indefinite integral. When we say indefinite, we just mean the integral of some f of x, some function that is continuous over blah blah blah, meets all the normal function requirements and the vertical line test, and then so we just mean we need to integrate something, some function, so that when we take the indefinite integral of this, notice there are no endpoints on the top of the bottom of the integration symbol, that when we do this, we're going to get a function that when we take the prime of it, we're going to get what we just put into this. So just a quick example of this is, of course, if you have the indefinite integral of 2x, then you know that the answer to that is just x squared, because what's the derivative of x squared? What's x squared prime? Well, x squared prime, let's just use the power rule, it's just 2x. I mean, it's a really obvious thing you learn in the beginning of any calculus course. So this is our derivative, so all this is saying, it's just a complicated way of saying what is a function that when I take its derivative gives me the f of x inside of this integration sign. So that's all that's really saying. So alright, let's go ahead and talk about what we're not talking about here. We're not talking about definite integrals, which, just really quickly, I've got a video on definite versus indefinite that goes into a lot more detail on this. But what we're not talking about is definite integrals, which do not give you functions, they only give you values of area. So if we have the integral of some function over a to b, then we're going to get that the v of that, or the value of our area, is some type of v of a of that. And so this is totally not what we need, because remember, definite integrals spit out values, whereas indefinite integrals take in functions and spit back out functions. So that's the beauty of that. So now let's actually talk about some of our rules for indefinite integrals, or primitive derivatives, antiderivatives. Alright, so one of the most important ones is if we have x to the n, if we want to integrate that, x to the n dx, I said x squared, man, come on, my bad here. If we have x to the n, so x to the nth power, man, I'm not writing well today, am I? Let's fix this here. So if we have the integral of x to the n dx, because we always have to write that, then a rule for this is x to the n, we can integrate it indefinitely by saying x to the n plus 1 over, sorry, not x, over n plus 1. So what's an example of this going to look like? So if we have, let's go ahead and integrate, and let's change colors here so we know we're doing an example. Let's do the indefinite integral of x to the 4th dx. What is this? What is this actually equal to? Well, let's just use this rule here. So we have on the top, we know that it's going to be, this is x to the n, so our n here equals 4. So we have x to the n plus 1, so x to the 5th is all that we're going to end up having on the top, and on the bottom we're going to have n plus 1, so 5. So look how easy this is in practice. Okay, let's change this. Let's pretend it's not x to the 4th. What if it's just, what if it's x to the 5th? Well, then that's just going to be x to the 6th over 6, right? For anything we do, it's always going to be that. So that's one extremely important rule. The indefinite integral of x to the n is just x to the n plus 1 over n plus 1. Alright, another good rule here is, of course, now think about it this way. What is the derivative of sine? Well, it's cosine. What is the derivative of cosine? Sine, so we can do it this way. We can say if we want to take the indefinite integral of cosine x dx, then we know that what are we going to have to take the derivative of to get cosine? Well, we all know that sine x prime is just cosine x, right? So since cosine x, right, it's just cosine in here inside of this indefinite integral. That's all it's saying. If we go back to what we originally talked about, this takes a function and spits out its antiderivative, or spits out a function that when you take its derivative gives you what you need. So this follows, think about a lot of that. I'm not going to do So I'm not going to do all these, like I said, but think about what I mean here. I mean that, let's just do some more of these trig functions here. So if we can think about it this way. Let's do this. Let's make a little chart. So over here, let's put in a straight line here. Over here on the right, we've got f of x, okay? And over here on the left, we have the indefinite integral of f of x dx. And so on the right, we're just going to have our initial function, our parent function. On the right, we're going to have its antiderivative. That's all this is saying. So we said what? Cosine x was just sine x, right? Because what's sine prime? Well, it's cosine. So sine x over here in the f of x portion, well, that's going to give us negative cosine, right? Negative cosine x, because negative cosine x prime is sine x. So secant squared x, because we know the derivative of tangent x is secant squared x. Secant squared x over here in its antiderivative, or its indefinite integral, is just going to be tan x. Right? So we should start to see the pattern emerging here. Two last important rules, and we'll talk about E when we finish. But what about this? What about 1 over x? Let's take its indefinite integral. What is this going to be? Well, think about it. What is ln x prime? Well, ln x prime is 1 over x. But we cannot say that the indefinite, we cannot say that the indefinite integral of 1 over x dx is just ln x. We cannot say that because this x here is going to give us negative values. We can't take log of negative values, so what we have to do is we have to say that this is ln of absolute x, because absolute x doesn't matter if it's negative or positive. It's just going to tell us our distance from 0. So the indefinite integral of 1 over x dx is ln absolute x. So this is really important, and it's easy to get tripped up saying, oh man, we have all of these easy rules for trig, so why can't we just do this for the natural log, or log base e? So now, since we know that ln is just simply saying log base e of something, right? So log base e of x is something. So we're talking about e. E is kind of important here. So what is the derivative of e to the x? Now this is huge, because we all know that the derivative of e to the x is e to the x. And by that logic, the second derivative of e to the x, and blah, 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 the derivative whatever, anything prime to e to the x is always e to the x. It doesn't really matter what it is. The infinite integral, or the infinite derivative of e to the x is just e to the x, so who cares? So what does that mean? Well, it means that this is the easiest function on earth to take the indefinite integral of. Since e to the x prime is just e to the x, the indefinite integral of e to the x dx is just, well, you guessed it, e to the x. So go back, take some screenshots if you like, do a quick review of this, and we should be good to go. These are just some basic rules. These certainly aren't everything, but these will definitely get you started being able to take indefinite integrals, or a nice way to say it, just antiderivatives of some pretty simple functions. So there you go.